Hi, welcome to class. My name is Don LaFawn, Professor Don, and this week in Cisco 2, we are covering Module 1, Basic Device Configuration. During the presentation, if you have a question and you're here with me live, please hold your questions until the end of the presentation. It's a good chance I'll answer the questions, but if not, we'll have a question and answer period. If you're watching it inside of our NetAcad class as a recording, please ask your questions in the help discussion forum. And if you're watching it on YouTube, please ask your questions in the comments section underneath the video. And I'll do my best to respond to your questions. I'm going to go ahead and share my screen with you. And a couple configurations that I have to do here. All right, so here we go. Module 1, Basic Device Configuration. We will learn how to configure initial settings on a Cisco switch. We will configure switch ports to meet network requirements. We'll configure secure management access to a switch. We'll configure basic settings on a router to route between two directly connected networks using the command line interface, CLI. We'll verify connectivity between two networks that are directly connected to a router. Configure a switch with initial settings. After a Cisco switch is powered on, it goes through the following five-step boot sequence. First, the switch loads a power on self-test, just like your PC does at home, that's stored in ROM. Post checks the CPU subsystem. It tests the CPU, DRAM, and portion of the flash device that makes up the flash file system. Step 2, next, the switch loads the bootloader software. The bootloader software is a small program that is stored in ROM that is run independently after the post successfully completes. Step 3, the bootloader performs a low-level CPU initialization. It initializes the CPU registers, which control where physical memory is mapped, the quantity of memory, and its speed. Step 4, the bootloader initializes the flash file system on the system board. And finally, the bootloader locates and loads a default iOS operating system software image into memory and gives control of the switch over to the iOS, the Cisco iOS. Now, the switch attempts to automatically boot by using information in the boot environment variable. If the variable is not set, the switch attempts to load and execute the very first executable file that it finds. The iOS operating system then initializes the interfaces using the Cisco iOS commands found in the startup configuration file. The startup config file is called the config.txt, and it is located in Flash. In the example, the boot environment variable is set using the boot system global configuration mode command. Notice that the iOS is located in a distinct folder and the folder path is specified. Use the command show boot to see what the current iOS boot file is set to. Let me turn on my laser. Whoop. Yeah. And you can see in this command boot system, your operating system, this is the file, this is the operating system, and it's located in Flash in this folder. Down here we have boot systems a command, Flash, and this is the path. This works exactly like Windows. You're looking for that last slash and something that ends with the bin, which indicates it's an iOS file name. Now, when you are powering on an equipment, you want to look for specific LEDs on your switch. System LED, SYST, the first one, it shows whether the system is receiving power. Actually, the next slide is probably better. All of these lights, it tells you what they're doing here, but this is the table that really you want to study when you're working on the labs because, for example, speed, if it's off, then it's in 10 megabits per second and running super slow. If it's green, it's 100 megabits. If it's blinking green, it's 1 gigabit speed, and the other ones are not optional. So what you want to do is you want to learn what each of these lights mean, what they actually do. And like I just said, the table here is an awesome table to practice remembering what the lights are. Recovering from a system crash. The bootloader provides access into the switch if the operating system cannot be used because it is missing or it is damaged. The bootloader has a command line that provides access to the file stored in flash memory. The bootloader can be accessed through a console connection using the following steps. Step 1. Connect a PC by console cable to the switch console port. Configure terminal emulation software to connect to the switch. Unplug the switch power cord, reconnect the power cord to the switch, and within 15 seconds, press and hold down the mode button while the system LED is still flashing green. Continue pressing the mode button until the system LED turns briefly amber and then solid green, then release the mode button. The bootloader switch prompt appears in the terminal emulation software on the PC. The bootloader command line supports commands to format the flash file system, reinstall the operating system, and recover a lost or forgotten password. For example, the dir command can be used to view a list of files within a specified directory, just like in a Windows environment. Switch management. Now, to prepare a switch for remote management access, the switch must be configured with an IP address and a subnet mask. To manage the switch from a remote network, the switch must be configured also with the default gateway. You'll be able, if you don't set up the default gateway to the router, right, your PC will be able to talk to the switch and other switches, other PCs that are connected to the switch, but without the default gateway, you won't be able to communicate outside of your own network. In the figure, the switch virtual interface, the SVI, on S1 should be assigned an IP address here. The SVI is a virtual interface, not an SVI here to the switch. It is a virtual interface, not a physical port on the switch. A console cable is used to connect to a PC so that the switch can be initially configured. Now, by default, the switch is configured to have its management controlled by VLAN 1. All ports are assigned to VLAN 1 by default. For security purposes, it is considered a best practice to use a VLAN other than VLAN 1 for the management VLAN. Step 1, configure the management interface. From VLAN interface configuration mode, an IPv4 address and subnet mask is applied to the management SVI of the switch. The SVI for VLAN 99 will not appear as up and up until VLAN 99 is created and there is a device connected to a switch port associated with the VLAN 99. Also, the switch may need to be configured for IPv6. For example, before you can configure IPv6 addressing on a Cisco Catalyst 2960 running iOS version 15.0, you will need to enter the global configuration command SDM prefer dual IPv4 and IPv6 default, and then reload the switch. I recommend, starting right from the beginning of this course, that you have a notebook that you take commands, that you add commands that you are going to need throughout this course, and also when you enter the field and you're a technician out in the field. If you are able to communicate with IPv4, but you're not able to communicate with IPv6, yes, you could Google that command, because I promise you, you're probably not going to do this command often enough that you're going to put it in memory, your memory. But You may. I know I don't, so I need my notes so that when I'm out in the field troubleshooting a problem, I can just refer to my notes. And I recommend you do as well. So here are the commands that you would actually enter. So the first thing you do is you go into config T, that enters into global configuration mode. Then you create VLAN 99 by you enter, they didn't create, they're creating VLAN 99 by going to interface VLAN 99. You can create VLAN 99 first, and then you can give it a name. I highly recommend you give it a name. That way it's less confusing when you look at your list of VLANs with the show command. So they really should have created VLAN 99 and then and then gave it the name command. Now you're in config, VLAN configuration mode at this point. They give it an IP address, then they give it an IPv6 address, then they type no shit to shut down to bring up the VLAN, then they type end, and then remember, after you do any configurations in a switch or a router for that matter, you need to copy run start, copy the running configuration file to the startup configuration file to ensure that when you turn off your switch, you don't lose all of your important configurations. Step 2, configure the default gateway. The switch should be configured with the default gateway if it will be managed remotely. Otherwise, you won't be able to talk outside of the network. You'll be able to communicate with, your signals will actually get to the switch, but then they won't be able to get back to you if you're remote. You enter configuration mode, config T, IP default gateway, give it a default gateway. It should be your edge router or the router you're connected to that's on the edge. And then end to get out of that, and then remember to save that command as well. You want to verify your configuration. You can do show IP interface brief and show IPv6 interface brief. Remember, I want to mention that when I first learned Cisco iOS and the CLI, I always wondered why it's IP sometimes and it's IPv6. IPv6 was quite obvious, but why is it IP? Well, remember, IP came before IPv6. So when you see show IP interface brief, it really means show IPv4 interface brief. The same command as show IPv6 interface brief. But because it came first and they didn't want to go back and rewrite the code, I guess, to be able to change that command, I personally wish Cisco would just allow us to write IPv4 interface brief and have that actually work. Maybe someday they will. Maybe they've changed it and they allow you to do it now, and I just don't know that. But when I went through the course, I would often get stuck. It's like, why IP? And now you know why. So the show commands are useful for determining the status of both physical and virtual interfaces. The output shows that interface VLAN 99 has been configured with IPv4 and IPv6 address. Note, an IP address applied to an SVI is only for remote management access to the switch. This does not allow the switch to route layer 3 packets like a smart switch, which you will learn about later in the course, which you can actually route layer 3 packets, but that's not what we're talking about here. We're just talking about accessing the switch remotely to be able to manage security features, for example, on the ports. So here we see VLAN 99 is the interface, and it is on 172.17.99.11, and it is down and down because we haven't actually brought it up yet with attaching it to the network. And then you can see the IPv6 addresses as well. Don't be confused by the FE80. Remember, that's a local link. It's automatically created when you assign an IPv6 address, and it is for communicating within a network. You're going to do a NetLab assignments. on this, NetLab 1.1.7, basic switch configuration. And remember, if you're using NetLab, the cabling is already done. Obviously, you're remoting into the equipment. You do not need to cable it. If you are using a packet tracer as somebody that's not in our NetAcad classroom watching out on the internet, you can use the packet tracer, and you will actually drag a console cable over to actually cable up the network and configure it. Configuring switch ports. Now, full duplex communication increases bandwidth efficiency by allowing both ends of a connection to transmit and receive data simultaneously. Remember, half duplex is like a walkie-talkie, where only one person can talk at a time. But in today's world, we're using full duplex. Rare will it be for you to run into half duplex in the world. You are using seriously old legacy systems if you're running into half duplex communication. But there are times when, like an ISP will incorrectly configure a network or a connection to you nhưng to half duplex because of some configuration inconsistency. Next thing you know, you're at half duplex. So it does happen. But we'll talk about that later. But that's why you should always manually configure your edge router on the exit port to your ISP. A micro-segmented LAN is created when a switch port has only one device connected and it is operating in full duplex mode. There is no collision domain associated with the switch port operating in full duplex mode. Unlike full duplex mode, half duplex communication is unidirectional. You push down the button, you can talk, you can't hear the other person, right? Half duplex communication creates performance issues because data can flow in only one direction at a time, often resulting in collisions. Actually, I should step back a moment. If your wireless access point, for example, is communicating, that actually is half duplex. You're broadcasting and then you're listening. You're broadcasting and you're listening. Obviously, with wireless, you cannot have a dedicated connection, right? Because there's no cable there. You're broadcasting and then unicasting too, but mainly broadcasting. Gigabit Ethernet and 10 gigabit NICs require full duplex connections to operate. In full duplex mode, the collision detection circuit on the NIC is disabled. NIC is network interface card. Full duplex offers 100% efficiency in both directions, transmitting and receiving. This results in a doubling of the potential use of the stated bandwidth. Switch ports and the physical layer. Switch ports can be manually configured with specific duplex and speed settings. The respective interface configuration commands are duplex and speed. The default setting for both duplex and speed for switch ports on the Cisco Catalyst 2960 and 3560 switches is auto. The 10-100 1 gigabit port operate in either half or duplex mode when they are set to 10 or 100 megabits and operate only in full duplex mode when it is set to 100 megabits, 1 gig. Auto negotiation is useful when the speed and duplex settings of the device configuration to the port are unknown or may change. When connecting to known devices such as servers, dedicated workstations, or network devices, or the ISP, as I was saying earlier, it is the best practice to manually set the speed and duplex setting. When troubleshooting switch port issues, it is important that duplex and speed settings are checked. Mismatched settings for duplex mode and speed of switch ports can cause connectivity issues. Auto negotiation failures create mismatched settings. I mentioned that earlier with an ISP. All fiber optic ports, such as 1000 base-SX ports, operate only at one preset speed and are always full duplex. So fiber is always full duplex. Here, we have a configuration, and we have to set manually. If we're going to manually set, we have to manually set the configuration on this side and on that side for these two switches to operate properly. If the two settings are not the same, you're going to get error message. Matter of fact, you're going to get an error message when you set this one to a set speed, and then that before you come over and set this side, you might get error message indicating that you've gone to half duplex. So be aware of that. So you enter configuration terminal, you go to the interface fast Ethernet FE01. The command is duplex whatever you want, full or half. The speed is the command, whatever speed you want, 100, 1000, and then end, and you're out. You have manually configured that port, and auto negotiation has been disabled at this point. Then you copy run start. Auto-MDIX. When automatic medium, this is the only place you are ever going to see. You might see it again in Cisco 3. The only place you're ever going to see it other than an exam. What does MDIX stand for? It stands for Automatic Medium Dependent Interface Crossover. Auto-MDIX. That's why I can't even say it without looking really hard at it. Medium Dependent Interface Crossover. You're not going to see that anywhere, but you're going to see Auto-MDIX everywhere. So when it is enabled, the switch interface automatically detects the required cable connection type. So if you have a straight through, but you really should have a crossover, it will automatically detect what cable is connected to it and then configure the connection appropriately. When connecting switches without the Auto-MDIX feature, straight-through cables must be used to connect devices that are the same, such as servers, workstation, or routers. Crossover cables must be used to connect switches and repeaters. Now, the reason why routers and servers and PCs, workstations, are all considered the same is because a router is just an advanced PC. A server is just an advanced PC, right? So they all have what a PC has. They all have CPUs and memory, and they're similar beasts. They're just created for different purposes. Now, a router or a repeater is different. It is not the same as a PC. It doesn't process information the way a PC does with the CPU. I won't get too deep into that. I think we covered a little bit of that, what switches and how switches communicate in this course. If not, you covered it in Cisco 1. With Auto-MDIX enabled, either type of cable can be used to connect to other devices, and the interface automatically adjusts to communicate successfully. On newer Cisco switches, the MDIX Auto Interface Configuration Mode command enables the feature. When using Auto-MDIX on an interface, the interface speed and duplex must be set to auto so that the feature operates correctly. Note, the Auto-MDIX feature is enabled by default on the Catalyst 2960 and Catalyst 3560 switches, but is not even available on the older 2950 and Catalyst 3550 switches. To examine the Auto-MDIX setting for a specific interface, use the show controller's Ethernet controller command with the PHY keyword. To limit the output to referencing Auto-MDIX, use the include Auto-MDIX filter. Now, again, that is a command that you want to add to your notebook so you have ready access for it, because the chances of you remembering show controllers, Ethernet controller with the PHY command is pretty slim, if you ask me. Now, here are some switch verification commands. You can do show interfaces, let's do the whole thing. So to display interface status and configuration, you want to use show interface and then whatever interface you're looking at, specific interface you're looking at. Display current startup configuration, that's the show startup config. Type it all out if you want. Do show start and then tab, you'll be fine. Display current running configuration, that's show run. Display information about the flash file, that's show flash. The system hardware and software status do show version. That's how you figure out the operating system. Just the history of commands, you can do show history to see what the last 10 commands is the default, but you can change that. Display IP interface about a specific interface. Show. I'm sorry. This is the one that you rarely want to type. Show interfaces up here, because if you type this, you're going to get a lot of information. If you just want a specific interface about if you just want the specific interface, here's where you put in an interface and then IP. But just going to show you the IPv4 interface information, IPv6 interface information for a specific interface. Or up here, all the information about a specific interface. And there's also the show interfaces brief command as well, which will give you all the information about but it'll condense it, right? Display IP information about. Oh, I already did that one. And then if you want to show MAC address interface information, you can do show MAC address table. And look, I love this. And this is what I was talking about with, I wish you could type show IP interface. I wish you could type show IPv4 interface, right? I wish that was true. Here they have you MAC-address-table, but you don't actually need the dash between MAC and address table. Well, if they can do it here, why can't they do it here? I don't know, but if I was in charge, I would make that happen, unless it costs $1 billion, and then I wouldn't. Show switch port. I'm not saying get rid of show IP. I'm just saying add show IPv4. All right. Verify switch, and here they just go through each one. So here, show running configuration. This is what you would see. This is obviously early in the configuration. All we've done is set an IP address, IPv4, IPv6 address, and a default gateway and interface VLAN 99. That's all we've done so far. Here they show interfaces and then a specific interface, and notice there's a lot of information about that interface. Here, show interface, fast Ethernet 018. This show interface, they're just showing you more information that you can get. Here it's up and up. Here it's up and up. Why are they showing us both? I think they're showing us the 100 is the speed, and over here they're showing that the speed has been changed. I really can't read that because my as well. It's what here they show. Oh, here's a problem. So the show interfaces command is used for detecting common media issues. One of the most important parts of the output is the display of the line and data link protocol status, up and down, etc. As shown. This is up and up, and then the next one must say up and down. I got to put on my glasses. I'm showing off by not having my glasses on, but I can't actually see the screen. Here, we're reading error messages. We got 3 input errors. We got 3 CRC errors. There's some collisions and some output errors. Here's some late collisions. You might say, what do all those mean? Here under the network classes, they break it down. So, and this was directly from Cisco 1. So input errors, that's the total number of errors, including runs, giants, no buffer, CRC frame, overrun, and ignored counts. Runs are packets that are discarded because they are smaller than the minimum packet size for the medium. For example, Ethernet packets are less than 64 bytes. Giants are packets that are discarded because they exceed the maximum packet size, and any Ethernet packet that's greater than 1518 bytes is considered a giant. CRC issues or errors are generated when the calculated checksum is not the same as the checksum received. Output errors, that's the sum of all of the errors that prevented the final transmission of datagrams out of the interface that is being examined. Collisions, the number of messages retransmitted because of Ethernet collisions. And late collisions, a late collision occurs after 512 bits of the frame have been transmitted, and then you get an error that's usually created because of incorrect cable lengths. You have cable lengths that are longer than they're supposed to be. Here we mention why you might get some of those. Input errors, the sum of all the errors, and then they talk about runt frames. Shorter than 64 bytes allow length are called runts. Malfunctioning NICs are the usual cause of excess runts. But they can also be caused by collisions, just like giants are longer. You can make shorter frames for the same exact reason. And CRC errors on Ethernet and serial interfaces. CRC errors usually indicate a media or cable error. Common errors include electrical interference. Maybe you've run your Cat5, which you probably shouldn't be using anymore. Maybe you've run your Cat5 over a fluorescent light, and that fluorescent light is actually creating interference on the line. And you should look for, and to solve that problem, you should look to say, hey, what could cause that problem? I actually had CRC errors at my home. I ran a Cat5 cable, it was like 5 years ago, 6 years ago. I ran a Cat5 cable 150 feet. I wondered when I was buying the cable why it was so hard to find a Cat5 cable that was 150 feet. But I found out afterwards, I'm thinking, whatever it was, whichever Cat I had at the time, I think it's Cat5. It was not Cat5e, it was just straight up Cat5. So maybe it's a little bit more than 5 years ago. But anyways, the cable length that I created, I actually dug a trench and I ran it all the way around my house out to my back deck so that I could have a hardwired connection to my TV that I have out on my deck. And sure enough, I got all sorts of errors over time. Fortunately for me, I solved the problem, not because I figured out that this was the problem, but there was a possum living under my deck, and the possum ate through the cable. For some reason, the possum decided Cat5 cable was delicious. It didn't just make a bite through it; it bit through it and ate like 3 feet of it. Anyways, when I replaced it, I jumped up to Cat6. Now, if I were doing it, I would probably do Cat7. But Cat6 I put out there, and I've had no problems at all. No problem, because Cat6 has a further range than Cat5 did because of the additional shielding. Anyways, little added example. Interface, the output errors is the sum of all errors. The show interfaces command will show collisions. Collisions in half duplex operations are normal. However, you should never see collisions on an interface configured for full duplex communication. Late collisions refer to collisions that occur after 512. I mentioned that. And excessive cable lengths are the most common cause of late collisions. Another common cause is duplex misconfiguration. So when you're troubleshooting issues, when your troubleshooting involves no connection or bad connections between a switch and another device, follow the general procedure shown below. So the first thing you should do is type show. By the way, you should, on your notebook, in your tech notebook, you should have a show command page, and I recommend you jump ahead 10 pages or 20 pages or whatever that you're going to think you might take notes in this class. Put it at the end of what you think you might take this class, the amount of notes you might take. 16 chapters, maybe you do 1 or 2 pages per chapter. So jump ahead that many, and then you might want to draw this out for troubleshooting. But definitely have all of your show commands on one page and what they actually do. It'll be very helpful when you're trying to figure out which is the best show command. So perform a show command. Is the interface up? If it is up, are there any indications of noise? If yes, remove the source, right? Turn off your fluorescent lights and see if you still have that problem. You can also verify duplex settings are properly set on both ends. If they're not up and up, then you want to verify your cable's connected. I took a class with an awesome professor here at this college, and that teacher told me that every single time a student has a problem, always make sure that they actually have the cables connected to the back of their equipment. Because once she had spent an hour troubleshooting a student issue, only to find out that the student's purse had been set on the cable, and it actually knocked the Ethernet cable out of the port. You know, some of the little tabs are broken on the Ethernet port, and this was one of those that was broken, and it had just slipped right out because the purse had knocked, or something, anything. It doesn't have to be a purse, had knocked the cable out of the port. And that's why, and she promised she would never make that mistake again. And I'm grateful that she told me that, because I have yet to make that mistake. I always look at the cables first to make sure they're properly configured. You can also check cables and connectors for damage. Maybe you also have a possum issue. Oh, by the way, the possum has not eaten my Cat 6 cable yet, so I'm thankful for that. Maybe it doesn't taste as good. I don't know. You also want to verify speed is properly set on both ends. Now we go to, is the problem solved? Yes, great, you did a good job. Congratulations, pat yourself on the back, and time to head back to the office or sign out of the SVI. If the problem is not solved, then I love this. They actually say document the work and escalate the issue. I love that because the last thing your company wants you to do is to spend 3 hours troubleshooting a problem. If you exhaust your your knowledge level, then you need to escalate it to the next level. We see that all the time when we call somebody like somebody online. Like, I have AT&T phones, and when I call them and I have an advanced question, the first person that answers the phone, her job is to change passwords. So after a little while, she says, "Oh, this is beyond what I can help you with. Let me get you to level 2 support." Or maybe I get to level 3 support after level 2 can't solve the problem. Ultimately, somebody's going to fix the problem, and it's just somebody with more knowledge. So if it's not you and you've done what you can, don't waste the whole day there. You need to continue on and complete more tasks to earn your pay. Escalate the issue, and then check back later and find out what the issue was so that you can learn from it. Maybe you're lucky enough that you can stay or stay on the line, or actually stay in person and watch the tech with more experience fix the problem. It may even be the more experienced tech that runs into a problem, and you took my class and you said, well, maybe a purse knocked the cable out, and you can help that technician, tech fix the problem, even though you are not the advanced tech. So it might help for you to be there. We're going to talk about securing remote access. We did a little bit of this in Cisco 1. Remember, Telnet is not secure. Telnet uses TCP port 23. It is an older protocol that uses unsecure plain text transmission of both the login authorization, username and password, and the data transmitted, the data itself, between communicating devices. A threat actor can monitor packets using Wireshark, for example. In the figure, they provide an example where you can read the password, you can read the username, and then you can actually capture the data, because it is all in unsecured text. So you definitely want to secure your text. Now, SSH, Secure Shell, is a secure protocol that uses TCP port 22. It provides a secure encrypted management connection to a remote device. SSH should replace Telnet for management connections. SSH provides security for remote connections by providing strong encryption when a device is authenticated, username and password, and also for transmitting the data between the communicating device. This figure shows you what the data actually looks like. This is the actual data that is captured using PuTTY between a connection. And notice you cannot configure, you cannot determine where the password and sign-in is, and obviously then you can't also use the data that you see. So always use SSH when SSH is a possibility. Verifying switch supports SSH. You're looking for the K9, is that right? Yep, you're looking for K9. Here's the operating system. And when you see K9, here's K9 right here. It indicates that you can use SSH and it is capable of going secure. Configuring SSH. Before configuring SSH, the switch must be minimally configured with a unique host name and correct network connectivity settings. Verify SSH support. Use the IP SSH command to verify the switch supports SSH. If the switch is not running in iOS that supports cryptographic features, this command is unrecognized. You can do show version as well. Configure the IP domain. Configure the IP domain name of the network using the IP domain name and then give it a name, global configuration mode command. Then you generate RSA. By the way, it doesn't matter what that domain name is. The only reason they're asking you to put a domain name in it is because the next step uses that domain name, Cisco.com, NetAcad.com, yourcollegename.com, whatever, to generate a unique RSA key pair, which automatically enables SSH. Use the crypto key generate RSA global configuration mode command to enable SSH server on the switch and generate an RSA key pair. Remember earlier I covered, or you learned in Cisco 1, I covered that you can use the question mark. Whenever you're at first, when you're going through configuring SSH, and you have to remember this keys, crypto key generate RSA global, right? Well, you don't type global. But when you're typing that out, all you got to really remember is the word crypto. If you think I'm setting up a secure SSH, I need to put this data in crypto, then you got the first word. Then just do crypto question mark key question mark generate, right? And then you'll get through it. Then you generate the, then to delete the RSA pair, use a crypto key zeroize RSA global configuration mode command. So the command is crypto key zeroize RSA. I didn't even know that was a word before I took Cisco. After the RSA key period is deleted, SSH server is automatically disabled, and you can reconfigure it if you want. Configure user authentication. The SSH server can authenticate users locally or using an authentication server. To use the local authentication method, create a username and password pair using the username, then give it a username, secret, password, global configuration command. So the username is part of the command. This is whatever name, this could be Bob, and then secret, and then whatever password you want it to be. Now, even this, when I went through Cisco 1, I thought it was always going to be, what do they, in this class they use Cisco and then password, whatever. I thought the command was username Cisco secret and then password 1. That's what I thought the command was, and I didn't understand this username can change. So you can have 10 IT people, each having their own username to be able to access the switch remotely. Maybe you had the same misconstrued understanding, but that's all they ever showed us. So when I finally had somebody, we were chatting, and they said they had something different in there. It was username Bob, secret, the secret password could be blue, right? I was like, Bob? What do you mean Bob? Anyways, step 5. Then you configure the VTY lines. Enable the SSH protocol on the VTY lines by using the transport input SSH line configuration mode command. Use the line VTY global configuration command, and then the login local if you're using a local database for your SSH for the local user database. Remote we talk about later. Enable SSH version 2. By default, SSH supports both versions 1 and 2. When supporting both versions, this is shown in the when supporting both versions, this is shown in the show IP SSH output, as shown in version 2. As supporting version 2. Enable SSH version using the IP SSH version 2 global configuration command. Now, because the next slide doesn't actually walk you through these steps, I went ahead and found a video that does. So I'm going to pause this recording and I'm going to open up that link, and then I'll be right back. And then if you're watching this as a recording, you won't even notice. Okay, I've loaded up the website. I found this video to give full credit. I found this video on networklessons.com, and it's how to configure SSH on a Cisco iOS. Super simple. I do recommend this website to gain some in-depth tech knowledge in networking. But here is the video.
Hey there, this is Rene from NetAcad. This video will show you how to configure a SSH server on a Cisco iOS router. So let's see what we have. Let's go to R1, the first router. And here I will configure SSH. There's a couple of things we have to do. First of all, you need to set a host name. So host name, let's call it R1. We need to set a domain name. Let's pick networklessons.local. And then we need to generate a key. So key generate RSA. And SSH, it uses a RSA public and private key pair. And the name of this key, so as soon as I hit this command, you can see that it will use this name for the key pair.
There was a little glitch there. Let me continue.
Key pair. And the name of this key, so as soon as I hit this command, you can see that it will use this name for the key pair, the host name and the domain name. Okay, so it asks me how many bits I should use for the key length. So there's a couple of things you can do here, and I'm going to pick 2048 bit. And the bigger the key length is, the more secure your key will be. And at the moment, 2048 is pretty much the minimum you should use. So a key length of 512 or 1024 is not considered secure anymore. Okay, so let's go for 2048. And you can see that it takes a while to generate these keys. I'm using Cisco Viral here, so it only takes 3 seconds here. But if you're going to do this on a real router, then it might take a bit longer, a couple of minutes. Okay, so now we get the key pair. And you can see that it enables SSH version 1. something. What we should do is switch to version 2. Version 2 is far more secure than version 1. Okay, what else do we have? So SSH is enabled, we got the key pairs. Let's go to our VTY alliance. And I want to make sure that we only can use SSH. So we don't want to support Telnet, only SSH. The other thing we have to do is specify login local. And this means that the router will use the local database to check for a username and password. So let's create a username. Let's say admin, password. And I'm going to use my _password as the password. Okay. So that's all that you have to do. This router will now accept SSH connections. Now you can boot up PuTTY to establish a connection from your computer, or you can use another Cisco iOS device like a router. And that's what I'm going to do here. So R2 will be the
anyways, and then they go ahead and access the equipment. So I want to stop this video now, and I did find that video on YouTube at how to configure SSH on Cisco iOS with networklessons.com for full disclosure. And you can find the same video. It's out there now. Let me close out of that. We're back to the PowerPoint, and I'll go back to the slide. So, and they give you an example here to verify using such as PuTTY. Go ahead and try to sign on and use your password. You should be able to get in. If you use a different password, you should not be able to get in. And you can also do a show IP SSH to see what version you're using, and then show SSH to see if you have any active configuration connections running. If you do, it'll show you. You're going to do a packet tracer 1.3.6 to configure SSH. Basic router configuration. Now, Cisco routers and Cisco switches have many similarities. They support a similar modal operating system, similar command structures, and many of the same commands, switches and routers. In addition, both devices have similar initial configuration steps. For example, the following configuration task should always be performed. Name the device to distinguish it from other routers and configure passwords as shown in the example. So here we have gone to config T. We give it a host. We give it a host name, enable secret, and then this is the password. Go to console, your console line, put a password on it. Go to your VTY lines, put a password on it, and then service password encryption to encrypt all of those passwords. I'll take a moment to also mention that there are 16 VTY lines. Now, when you say line VTY 0 through 4, you're indicating that there are 5 connections to the network remotely. A previous instructor that I took said that you should never have more than 3, because it would be you remoting in, it would be the person, the tech support person helping you, and then their supervisor. I'd like to suggest that you would at least have 4, because you'd also have your supervisor that could conceivably want to remote in as well. So that's 4. So it really should be 0 through 3 should be enough. That professor said that there's never a reason that you would want 16 people logging or remoting into a switch. That's just not the way it works. You want to configure a banner to provide legal notification. So it should say banner, MOTD, message of the day, and then whatever the opening symbol is, you got to close with that. So don't use any symbol that you would use on a regular basis. Maybe you want to use £sign would be a good one that you generally don't use often. Then once you do all of the configuration, whether it's a router or a switch, you want to copy your running configuration to your startup configuration so you don't lose all your hard work the next time the switch is disconnected. Now, dual stack topology, one distinguishing feature between switches and routers is the type of interfaces supported by each. For example, layer 2 switches support LANs. Therefore, they have multiple fast Ethernet or gigabit ports, 28 for example. The dual stack topology in the figure is used to demonstrate the configuration of router IPv4 and IPv6. Now, a router doesn't generally have 28 connections. It's limited to 2 or 4 connections. Now, the reason why they say dual stack is because we have both IPv4 and IPv6 addresses that have been configured in our equipment. So here, I'm just going to point it out that this network is the 10 net. Oops, let me turn on my laser whip. Hang on a second. So this network's the 10 network. It has both an IPv4, IPv6 address. Its default gateway is G000 on R1, and here's the 11 network. Here's the 10.1.1.0. So this is the 1 network, and that's would probably be the 2 network. Yep. And then, of course, we have this interface, and that's just IPv4. Then you got all the IPv6 addresses as well. So you got the 1 network, 2 network, 3 network, 4 network, and 5 network. Now, you should know this already from your subnetting class in Cisco 1. So I'm not going to get too far. I'm not going to explain that. If you don't know what I just said, you need to brush up on your IP address subnetting and your IP address allocation knowledge. Now, routers support LANs and WANs and can be interconnected and can interconnect different types of networks. Therefore, they support many types of interfaces. For example, G2 ISRs have 1 or 2 integrated gigabit Ethernet interfaces and high-speed WAN interface cards, HWICs, slots to accommodate other types of network interfaces, including serial, DSL, and cable interfaces. To be available, an interface must be configured with at least 1 IP address, because it could have 2. It could have IPv4 and IPv6. And IPv6 could also have a local link address. So there could be at least 3 addresses on there. Use the IP address, give it an IP address, an IPv, and a subnet if you get an IPv4 address, and the IPv6 address, and then whatever address and prefix interface configuration commands to go ahead and assign those IP addresses. Activated. By default, LAN and WAN interfaces are not activated. They are all in shutdown. Remember, a switch is all up. Everything is running. You could take a switch out of a box, connect a port to it, and it's off and running. But a router is everything's down, and you actually have to bring it up by typing no shutdown. The interface must also be connected to another device. Obviously, if you're going to have some sort of communication, you have to be connected to somebody else. And that other device can be a hub, a switch, or another router for the physical layer to be active. Even a PC or any kind of, not that it's usual to connect a host like a PC or a laptop to a router. It is possible. Description. Optionally, the interface should also or could also be configured with a short description of up to 240 characters. It is a good practice to configure a description on each interface. On production networks, the benefit of interface descriptions are quickly realized as they are helpful in troubleshooting and in identifying a third-party connection and contact information. It's also helpful when you're routing, when you're accessing a router remotely and you are looking at the port, you're actually able to see what the purpose of the port is. You can't just look at the cable to see where it's going. Not that that's very useful either. Here they actually show an example of the configuration for all of the router ports in that topology I showed you earlier of R1. Notice R1 has 3 interfaces, G0, G01, and G000. Serial 000, gigabit 000, and gigabit 001. We have an IP address for IPv4 and IPv6, and then a description, and then no shutdown to bring it up, and you're good. Then you go to the other interface, you do the same thing. You give it an IPv4, IPv6 address, and then a description, bring it up by saying no shutdown. And then you go to our final interface, the serial interface, give it its IP addresses, give it a description, and then bring it up. Now you can also have loopback interfaces. Another common configuration of interface iOS routers is enabling a loopback interface. The loopback interface is a local interface that is internal to the router. It is not assigned to a physical port and can never be connected to any other device. It is considered a software interface that is automatically placed in the up state as long as the router is properly functioning. The the loopback interface is useful in testing and managing an iOS device because it ensures that at least one interface will always be available. For example, it can be used in testing purposes, such as testing the internal routing process by eliminating networks behind the router. So if you check your loopback, for example, you will ensure, and it works, well, then now you know your TCP/IP stack is working properly. It's probably not your problem, a physical or a network problem connecting to another device. If you're able to talk to yourself, unlike humans talking to yourself under a bridge, that's probably not an indication you're okay. But if you're a router and you can talk to yourself, then you're in good shape. For example, you can create multiple loopback interfaces on a router to simulate more networks for configuration practice and testing purposes. The IPv4 address for each loopback interface must be unique and unused by any other interface. In this curriculum, we often use a loopback interface to simulate a link to the internet, often the ISP. Enabling and assigning a loopback interface is simple. Interface loopback and then give it a number. And then you got to give it an IP loopback 0, for example, loopback 1. And then IP address, give it an IP address and a subnet, and then you're off and running. You're going to do a packet tracer 1.4.7, configure router interfaces. Next thing we talk about is verifying directly connected networks. And here we're going to learn about the show commands that I mentioned earlier. There are several show commands that can be used to verify the operation of a configuration on an interface. You can do show IP interface and then IPv interface brief. You can do IPv6 interface brief, and that will display a summary of all of the interfaces, including either IP or IPv6, depending on which one you ran, and their current operational status. You can do a show running config interface and then give it a number, and that will display the commands applied to a specific interface. That's not one that we use very often, so that would definitely be helpful for your tech notebook. You can do show IP route and show IPv6 route to display the actual routing tables for IPv4 and IPv6. Here we see an IP, and I'll show you all those commands in a moment. So here's show IP interface brief, and you can see the 4 interfaces that are on our router and whether they're up and up. They all look like they're up, except for the serial 1.0.1.0, which we did not configure. Below that, here they do the show IPv6 interface brief, and you can see the IPv6 ports and the fact that they're all up and they've been properly configured, and they've created their own local link addresses. The output of the show IPv6 interface brief command shows 2 configured IPv6 addresses. They just go through and explain. Here I do want to read, a local link address is automatically added to the interface whenever a global unicast address is assigned. An IPv6 network interface is required to have a local link address, but not necessarily a global unicast address. Remember, global unicast address reaches out to the world. A local link only communicates within the local network. And here is the results of show IPv6 interface gigabit 0.0.0, and you can see that it's been that IPv6 is enabled, and that the local link address has been set, and then you can see that it has also joined some groups as well. Local link groups, like all the routers and all the host devices. The output of the show running configuration gives you information about the running configuration. Obviously, when you add in interface gigabit and then a port number, then you get information about that port number, specifically the IP address, what kind of, if it's in negotiation, if it's in auto negotiation or manual, the IPv6, IPv4 addresses. And here is the IPv4 show IP route, which shows you the which shows I can't do it. I used to be able to. I can probably let me see if I can zoom in. I'm going to do it one time with you guys, and I'll freeze the network if it doesn't work anymore. Okay, so hang on just a second, and I'm going to zoom in. I had a problem with my computer for a while where I wasn't allowed to zoom in. That's not what I wanted. Zoom in here. This is zoom in. Because I'd rather show you the. Let's see if it works. Getting there was always fine, but coming out wasn't. We'll see if it works. Show IP route. So here, this is your routing table, and you can look at your routing table. You can pretty much disregard these networks. They basically are the network, the parent network for these childs, but we don't. It was really a legacy technology that created these. They just haven't removed them. But this is what you're looking for. We have a directly connected network, 10.0. This is the network. This is the link. This is the actual IP address on that port that's connected. /32 tells you that it's one address, and it's directly connected to 0.0.0. So now you know the network that's connected and the IP address it's connected to. Same thing here with the 11 network. This is the network directly connected. That's what the C stands for. And then the link, this is the link connected port, and it's a 32. So we know where 11.1 is that port. And you can see the same thing in the 200 network. It's /30. It's got 4 addresses, remember? And then one of those addresses 225 by the 32. Now below you can see IPv6 route. IPv6 notice it doesn't have the parenting because parenting in IPv4 is old technology. IPv6 of course is newer, and IPv6 didn't include class full addressing. The reason why we have parenting is it's a leftover from class full addressing. Anyways, so IPv6 just has the connection, and then by what port to network, and then here's the actual IP address that's been assigned, and then same port. And then here is the 2 network, the 3 network. They have they're connected. This is the network address. The network : is the network, and then : 1 is the IP address all the way down. Right. Okay, so I'm going to go ahead and come out of that, and we'll continue. And I just mentioned what the C was, and and I also want to know. Remember up here it was /32. I showed you that. Well, in IPv6, remember there's 128 bits, so this is /128. It says one address. You can filter the show command to just get some information. You can use these filters. I call it the stop command. They call it the pipe command. But after the show command, you can pipe a section which shows the entire section that starts with the whatever you're looking for. You can include a specific output. You can exclude specific output, and it can also pipe to begin at a specific area of, for example, the running configuration. Running configuration could be very complex. Maybe you only want to see the VLAN information. So you would do show run pipe begin VLAN, and it would jump you down to the VLANs. Okay. You can also, the default is 10 for the command history, but you can also change that. Sometimes you want to change it to be able to look further back when you are typing. So, for example, this is the command terminal history, and then you put the size afterwards. And I got an excellent example by a student of mine several semesters ago, and that student told me that they had a disgruntled employee that they were having all sorts of network issues, and they couldn't figure out why they were having network issues only occasionally. So they determined who was working when the problems were actually happening and narrowed it down for 1 or 2 people. And then what they did to find out what was actually happening, to prove that a specific person was actually making the commands, they changed the history size to 200. from 10. And so once they changed the terminal history, all they had to do was click the up button, the up arrow, and then they were able to see everything that disgruntled employee was actually typing in the command, in the CLI, the command line. So they were able to catch the person in the act and see exactly what they were typing to create the problems. So anyways, I'm not saying that's going to happen in your world. I'm just saying it's a possibility that if you want to see more than the last 10 commands, you can use that command to do so. You're going to do a packet tracer 1.5.10, verifying directly connected networks. And then you're going to use a packet tracer to implement a small network, and a lab to configure basic router settings. And that is the end of our very first presentation. So let me go ahead and get out of this window. And again, my name is Don Lafon, Professor Don. It is my pleasure to teach you Cisco 2. Hopefully these lessons are useful. Remember, the lessons that I teach you here are only really to supplement what you learn, whether you're within our Cisco NetAcad class here at the college, or you're learning this content on your own using some of the resources that you've found online. Anyways, it's been my pleasure. If you have questions and you're with me live right now, please hold on for a few minutes and I'll give you an opportunity to ask those questions. I'll answer them. How about that? And then if you are watching this in our classroom later than our presentation, please ask your questions in the help discussion forum. And if you're watching it on YouTube, in the comments below would be a wonderful place to ask questions. Remember to thumb up the presentation if you enjoyed it. If you have any recommendations for me inside of YouTube on how to do this better, or in the classroom as well, please let me know. I'll be happy to consider your recommendations because we all want to improve, don't we? So again, my name is Don Lafon, and I'll see you again in module. I guess my dogs will see you then too. I'll introduce you to them at some point when we're not in a long presentation. How about that?